Here's our train. So this is what Thomas actually is. He's a modified austerity tank locomotive with a configuration 060. There's some stats for Thomas. You've got his width and you've got his height there. You can probably see he's a steam train. When you're making your model train, some ideas of how you could do it. You could try and make a paper mache one. You could find some household objects that will fit the right shape to make your train and then try and make it paper mache. There's lots of information online about how you can make paper mache, either using glue or using flowers, different ways of doing it, so look into that and obviously get permission first. If you're lucky enough to have Play-Doh, you can make a Play-Doh model of the train. There's also information online about how you can make Play-Doh at home, but obviously get permission first. And if you have the skills and access to wood, and with adult supervision, obviously, you could try and make an actual wooden model of a Thomas the Tank Engine, or, like this boy here, you could just make yourself into Thomas. Why not? Go running through some tunnels around the house. See if you get gauge clearance. So, will my train fit through the tunnel? That's the question. So we've got the width and the height of our train. So there's the train dimensions, 8 foot 9 inches, height 12 foot 7 inches, and the tunnel dimensions is 6 foot wide and 8 foot 6 inches. So, nah. Thomas is not going to fit. He would smack right into that tunnel. He'd take his head off. He's not going to fit through. He's not going to get gauge clearance. He'd have to go a different way. If he was been put through by freight, they'd probably try and move him around on a diversion on a different route. He would not fit through this way. So what we can say to Thomas is, you're better off staying at home. Stay safe, stay at home. So next off we're going to look at calculating surface area of your train. You can probably see there's quite a few different shapes. I just made a quick Play-Doh model of a Thomas the Tank Engine train there. I didn't have any blue Play-Doh, obviously, but it all dried out, so I only had yellow that worked. Probably noticed multiple shapes, so one of them is a rectangle. To calculate the surface area of a rectangle, it's just length times width. So I measured out the rectangle here, assuming that is a rectangle, and it had a length of 4.8 centimetres, so long size 4.8 centimetres, and then we had a width of 2.5 centimetres. So use this little multiplication table to times them together. You've got the units 4 and 2, and temps 0.5 and 0.8. So you do 4 times 2, get 8. 0.8 times 2, 1.6. 4 times 0.5 makes 2, and then 0.8 times 0.5, where you are just halving 0.8. So you end up with 0.4, then you add those all together and that gives you the surface area for the rectangle of 12 centimetres squared, and it's centimetres squared because you're also timesing the centimetres together, and just like if you were timesing so numbers together, so 2 times 2 or 3 times 3, so 3 squared, 2 squared, it's the same as centimetres. Centimetres times centimetres, you end up with centimetres squared. We've also got a circle here for Thomas's head. To work out the surface area of a circle, it is pi r squared, and you end up with 19.63 centimetres for that one. So pi r squared to work out the area of a circle. Semicircle, what do you reckon you might do for a semicircle? So it's pi r squared is the formula for a full circle. What it might be for a semicircle? Pi r squared divided by 2. There's the working out for this one. So the radius is half the circle from the outside to the centre. That's the radius, and we're doing the radius squared. So it's pi r squared, and you end up with 4.54 centimetres squared to 2 decimal places. And if you have a shape that's made up of a few different shapes. For instance, sort of L-shaped one here can be split into two different rectangles, and then they can be added together. And you also do that when you're adding up surface area for the total of your shape. Some other ideas which go along with this: you could draw out a model of your house, and you see they've used square paper there. That's quite useful, especially when you're first calculating area for younger children as well, so you just count out the squares, especially if you've got centimetre squares. It's very useful. So one activity could be for the child to map out your house, measure it, work out the surface area of different rooms. Could be quite a good activity. They could also get an idea of how far they've travelled each day by mapping out their route around the house and try and calculate that. You can also have a go at trying to calculate your own surface area or volume by dividing your body up into different shapes, measuring it and trying to work that out. Just a couple of activities you can have a go at while at home. Next up, volume. So in this we're assuming, to calculating volume, we're assuming Thomas is a big cylinder. And these are his measurements. To calculate the volume of a cylinder, you use this formula here, pi r squared times h. So for this we're going to, like I said, we've assumed Thomas is morphed into the shape of the cylinder. We're going to half his height, so the height of Thomas, to work out the radius, which we're going to use for this sort of front portion. So imagine that's flipped 90 degrees on its side, and his length is going to be this h value. So we're trying to calculate Thomas's volume as a cylinder in metres. So first off we're going to convert from feet to metres. So his height is 12 foot and 6.381 inches. So in 1 foot there is 0.3048 metres, and in 1 inch there is 0.0254 metres. Therefore 12 feet is 3.6576 metres. So what I've done there is times that one by 12, and because they're proportional to one another, which is the same on that side, so times that by 12, also times that by 12, and that's what you come up with. And the same applies for the conversion to metres and inches. So with this I've had to times it by 6.81 to change 1 inch into 6.81 inches, and you can do the same thing to this side because they're proportional to one another, and that's what you get. Add them together and you get your diameter. So that'll be the diameter of Thomas that we're using for the, because we're flipping our cylinder over, remember, so that'll be the diameter of Thomas. We want the radius, so we have to halve that, so we do 3.83 metres divided by 2, and that gives us 1.915 metres for our radius, our R figure here for Thomas. Next we need to work out our H figure, which is actually going to be our length for Thomas, and we've got to convert that one as well. And we can see that he's 30 feet and 4 inches long. So 30 foot to metres, it's the same conversion as last time, and it gives us 9.44 metres. 4 inches is 0.1016. Add them together, and hey presto, we've got his length. So remember again, we flipped it over like that, so he's 9.2456 metres long. So we can then plug those figures in and work out Thomas's volume. So that's pi times r squared times that h figure, which is actually his length. and that gives us approximately 106.5 metres cubed. Do you think that's accurate? Is it an underestimate, an overestimate? Why do you think that? Have a little think about that. I hope you've enjoyed this presentation and learnt something about some maths, calculating surface area, volumes, about calculating time, and also I hope you found a little bit of something about being an operational planner and how that might work, and maybe you might consider working at Network Rail, working as a planner in the future as a future career.